So here we've got the first problem that we're working on for our next set of practice problems. I wanted to give you, again, another example just to get used to this idea, seeing some more example problems, because every time we see another one, every time we work another one, it becomes just a little bit easier. I went ahead and I rewrote our continuum to be able to tell where we're at and what it is we're doing. The first thing, when you come across a problem like this number 5 just screams at you. It just says, balance me, balance me. So let's balance it. We got some open blanks. Let's take care of our coefficients. So first things first, we need to get that all of the elements on one side of the reaction are equal to the number of elements and atoms on the other side. Well, pick an element. Doesn't really matter. Pick one, see if it balances. We got two hydrogen. All right, they're good. We've got an SO4 sulfate, an SO4 sulfate. Perfect. We've got a calcium. So far so good. We've got a carbon, 3 oxygen. Be careful here. 1, 2, 3 oxygen. So it may look like it's big and complicated and confusing, but really when you take a minute and observe, it's actually a 1, 1, 1, 1 reaction. They're all already balanced. All we need to do is put in our coefficients. So as we look, let's go back to our problem, see what it is they're starting us with, see what they're trying to get us to solve for. So how many grams of calcium sulfate? I see a question word. How many grams of calcium sulfate, that's what we're looking for, can be obtained from a reaction of 154.5 grams of calcium carbonate. Go ahead and put that guy over 1. Just like MapQuest, where are you starting? What's your given? Where's your final destination? Where are you trying to get to? Your units are going to be your guide, your street signs, your map posts along the road to success. Alright, we're starting in grams. Let's find grams up above. Looks like we're starting here with grams of our first substance. And we're trying to solve for, grams of our new substance. This tells me that we actually have 3 different conversion factors that we're going to need to use to get to our final location. We're going to need the molar mass of the first substance. We're going to need a mole ratio. We're going to need a molar mass for the second substance. All right. Let's go ahead and start by finding the molar mass of calcium carbonate. So we've got a calcium, a carbon, 3 oxygen. When you add all of those up, you should get a molar mass of 100.09 grams per every 1 mole. All right. If grams are on top right now, I gotta love units. Grams on top here, they better go on the bottom of the next step. 100.09 grams will equal 1 mole of this substance. In this case, it is the calcium carbonate. Grams cancel. Now we're into moles of CaCO3. As we check, we're now in moles of A. We can now use our mole ratio. Awesome, we can use ratio. And if you remember, ratio comes right from the coefficients. We're curious in this particular problem about calcium carbonate and calcium sulfate. So let's go ahead and put in our ratio. We know that for every 1 mole of calcium carbonate, we will produce 1 mole of calcium sulfate. Cool. Moles cancel. We're now into moles of calcium sulfate. Now I know what you're thinking. You're thinking, Mr. Jorgensen's being stupid again. That's a 1-to-1 ratio. That's not going to change anything mathematically. En contraire. It is going to change things because we've changed the units. Not only have we changed the units, but the ratio will not always be a 1-to-1. You always have to have that mole ratio step in there, even if it is a 1-to-1. You gotta show me that step. Shows me your work, shows me what you're thinking. Alright, now that we're in moles of calcium sulfate, we need one final step. We're in moles of our new substance. We need the molar mass of our second substance to finish out this problem. So we're going to add a calcium, a sulfur, and 4 oxygen. When you add these together, you should get 136.15 grams per mole. If we have moles on top right now, our 1 mole goes on the bottom. For every 1 mole of calcium sulfate, we have 136.15 grams. Moles cancel. We're in grams. Bada bing, bada boom, Bob's your uncle. All we have to do is solve. So multiply the top, multiply the bottom, divide it out, and you should get, for this particular problem, a final answer of 210.1626, It goes on for a while. And this is grams of calcium sulfate. Cool. Congratulations. Nicely done. Please tell me somebody is just yelling at their screen right now. What's wrong with this problem? We're not done yet. Trick question. We need to check our sig figs. We started back at the very beginning. 1, 2, 3, 4 significant figures. This has far too many significant figures. If we count from left to right, 1, 2, 3, 4, those are the significant figures we want to keep. What's the next digit going to do to our last significant figure? Well, the 6 is going to round it up. Our final answer here will be 210.2 grams of calcium sulfate. Another wonderful example problem for you to see, to be able to watch this process in action. Now, the cool part is that if you needed to stop somewhere in between, you would just stop. For example, if we want our final answer in moles, we just wouldn't do this last step. We would stop in moles of B. Let's say you started in moles of a substance. You would skip the first part. You would start right at the moles of your first substance. So following those units is paramount to our success in our stoichiometry, in our calculations. Cool. You try these last 3, see how they go. Those are going to be our homework for tomorrow. If you have any questions, as always, please feel free to shoot me an email or get a hold of me before or after school. I'm more than happy to help you out. Good luck.